Hi everyone, my name is Sergii Kozyrev. I'm an Android engineer here at Atlassian. And yeah, we're going to talk about some practical Android architecture. First couple of important points. Please save your questions to the Q&A session. There is a dedicated slide for this. But please be interactive. I'm going to ask you questions and try to interact with you. So, woohoo, we're going to do this together. All right. Yeah, practical Android architectures again. Before talking about Android architecture, let's talk about what is software architecture. Anyone has any idea? Just hands up. Yeah? Yeah, just say it.
How you build software?
Yeah, exactly. That's right. So one of the possible definitions is the definitions that I do like, is that the software architecture actually represents the set of principal design decisions that it has to take to explain how this software is built or how you're going to build this software. But why do we need this like architecture stuff? Isn't just writing some activities, parsing JSON, put it into the views? That should be enough, right? Why do we need an architecture in the first place? Well, there are some benefits that architecture usually provides. For example, the extensibility, the ease of adding new features, and the maintainability, because like everybody knows how painful could it be to add or to fix some bugs like in the legacy code that has no architecture or no design principles in it. Yeah, there is another point not on the slide. For example, when you bring new developers, so you change developers in a team, that's truly important that they will be able to assess and like consume and understand this project just like easy. And this is where architecture is also very handy. Another point is testability. You are all probably very aware of the fact that, yeah, we need to cover it with unit tests, with UI tests, with espresso tests, with whatever tests to make it stable and to be sure that it's not going to break in future. All right. Now we have more interactive session. What are the currently widely used Android architectures? Please, yeah, just yell it.
God activity.
What?
God activity.
God activity, yeah. That's a wonderful architecture. That's good. More. I know you can do better. MVI. Okay, this is something like comparatively new, fresh. We're not going to cover this today, unfortunately. No, I will touch it a little bit. Some other? MVP. All right. I think you're just shy. You probably have heard and probably use it like model view model, model view controller, model view presenter, model view intent, like this unidirectional stuff and everything. All right. Well, there is a remark that MVP, MVVM, MVI, they all can be considered not only as architectural, so Android application architecture, but more like design patterns for the presentation layer. And because there are still like bigger field of view where we can talk about core architecture, like onion architecture, layered architecture, software-oriented, service-oriented, microservices architecture, all this stuff. But that's like a bit different point. We will talk about this as well. Okay, so just the quick walkthrough. I truly believe, well, first of all, with the previous slide, please raise your hand if you've used it like MVC or MVP or MVVM in your past in your experience. Yeah. That's what I thought. So we will not spend a lot of time on this. Just a quick refresh for ones who used, for example, only MVP and never used MVC or MVVM, something like this. So MVC, well, with MVC it's pretty straightforward. On Android, you just get it for free out of the box. Well, if you create a layout and create an activity, inflate this XML file, inflate this layout, you already have a view as your XML, as your view hierarchy, and the controller as your activity, or it can be a fragment or whatever. And yeah, you set click listeners, notifies controller, controller gets the data from the model or changes the data. And the controller, this is an important point. controller sets up the view. So controller knows everything about the view, and it controls it. It sets it up, and updates it. If we talk about model view presenter, this is pretty much the same diagram for all three of them, but view this time is represented as an interface, and presenter is represented as an interface. Exact implementation knows about interfaces of each other. So for example, presenter holds the reference to the interface, to the object of type of this interface, of the view interface, and vice versa. And yeah, presenter, just as with the controller example, serves as a man in the middle. But after all, presenter doesn't know about exact implementation of the view, and that's why it asks view to set up itself. So view should be like a little bit aware of how to set up itself, and this is how they are more decoupled or less coupled. In the model view model, as I said before, the diagram is pretty much the same. And yes, we have these amazing view models, and they are getting to be developed further and further with every Google I/O and the release of architecture components. But the important thing here, you remember where presenter asked view to update itself. Important part here is that view actually observes the changes. It can be view state changes or data state changes in the view model. So view model has nothing to do with view at all. It just exposes some sort of observable or live data. That's your choice. Okay, you remember I've told you that MVP, MVC, and VVM is this type of like design patterns for the presentation layer. And well, there are more out there in the world. There is a clean architecture. Everyone who are aware about Uncle Bob and his clean architecture and all the possible like permutations of the clean architecture implementation on Android, because there is no like stable and one way of doing this. We need to understand that this is not the only one. There are a lot of other like general purpose architecture frameworks and architectural like approaches that we can use. Just I wanted to cover this clean architecture because it saved me like a couple of weeks or maybe more, couple of months of time once, and I'm going to talk about this later. So on the clean architecture diagram, you can see the like green and blue boxes. So all the stuff that I've covered about, that I've talked about MVP or MVVM, this view presenter, view model, all the stuff is here in the presentation layer, okay? So the rest of it is a model. We haven't talked about model a lot till now. So the clean architecture proposes to have different layers inside a model, to have them separated and to be able to test them, to manage them, to fix them. You remember to scale them, to extend them like separately. One of the interesting parts here is that use case, well, yeah, sorry. If you talk about them one by one, presentation is a view model, a view presenter, and the use case is kind of like, yeah, it is a use case. It is what it is. So it can be like, what do we need to do to present the profile screen? Like probably get the session token, get the profile data, download it, or get it from database. Like it's just one use case. And they are going to be encapsulated like different use cases that you use in your applications. They're going to be encapsulated inside these use cases or interactors. I do like the term interactor. Domain here represents the entities. It's actually your business models, your business rules of your application. In case of newsfeed app, it's going to be like your article class, just a Pojo class or something, data class if you want, the Kotlin example. The data source, well, this is an interesting part. Yeah, I already talked that use cases can be, there's can be several use cases. Data source is something that you usually call probably repository. You've been doing some repository pattern, and it has like database and API. You call one, you compare some timestamps or whatever, like freshness, and you return the data. And by clean architecture, you have this framework, so what it is and why it is also green just as a presentation layer. So according to this part of the clean architecture, the middle layers, use cases, domain, and data should be platform agnostic. And if we use something like Kotlin native, or if we just like want to write some backend stuff on Kotlin with the same business logic, we can just copy and paste or just directly reuse use cases, entities like Pojo classes, and data repository. Just take it from there and use it here. It should compile and be just working. So this is platform agnostic, and presentation framework is supposed to be platform specific. But hold on a second. I've just referenced the repository pattern for data source. You've been doing this. I'm pretty sure you did. You had. And correct me if I'm wrong, but usually inside repository, you do use database and you do use some sort of retrofit or whatever API reference you need. How do you can keep data part platform agnostic and move something to the framework, which is supposed to have this API, DB, sensors, whatever, like platform. And yeah, but by saying platform specific and framework specific, I'm not referencing only Android platform. It can be like, we can also think about framework as like third-party libraries, like Glide or whatever, like classes that are not platform agnostic, all right? So yeah, this is actually a fair question. Here, I wanted to ask you about one more question. How many of you heard the term solid? Yeah, we have about 50%. That's good. That's very good. Do you remember the last word of this, the last letter of this abbreviation? What does it mean? Dependency inversion. Yahoo! I hope we can say it loud, like all together. Let's do it. 1, 2, 3. Dependency inversion. Yeah, cool. So yeah, in this case, you just need to apply dependency inversion. For those who are not aware about what is dependency inversion? Sorry, I'm jumping back. Dependency inversion says it's solid is a set of software design principles that are very often useful. And D, the last letter of a dependency inversion, says that it doesn't matter like if your components are high level or low level. Low level shouldn't depend on high level, and high level shouldn't depend on low level. In simple words, it's like, okay, you have like some sort of presenter, and you have like, I don't know, like view inflator or some sort of sensor class, like sensor manager, whatever. Sensor manager somewhere low level, and your presenter is like high level. They both should depend on abstractions instead. So they have to depend on abstractions instead of depending on each other. And this can be explained by an example like really easily. So if you look into this slide, the usual setups that you have, let's call it a room database for simplicity. It has just one API call, like get list of items, list of strings. And the data repository, you remember this data layer. It has a reference to the room database, and then you provide the API for it to call it from presenter, from view model, from wherever you want. Well, first step here is to apply inversion of control, which is quite different from the dependency inversion, but it's going to be a first step. Inversion of control is actually, it's a little bit another principle standing somewhere on the side. And it says, get the responsibility of creation of the object out of the class. So in this case, in the data repository number 1, data repository is responsible for creating this database instance, right? But in the data repository number 2, room database is just getting provided, like someone provided for you. And yeah, we can use dependency injection for this, like some sort of DI, Dagger, or Kotlin DI, whatever. But yeah, this is a dependency, inversion of control. And then we can easily apply dependency inversion. So we create an interface, call it data persistence, which has the method to return a list of strings. This is our abstraction. You remember low level and high level should depend on abstractions. And the data repository 3 has data persistence instead of room database injected into it, and provides and calls the appropriate method and returns the result. And room database, this is another instance, another class for our room database. It just implements our abstraction data persistence. In this case, actually both room database depends on the data persistence, which is an abstraction, And data repository number 3 also depends on an abstraction, right? Because this abstraction is injected into it. So this is how we decouple it. And this is how, on the previous slide, well, yeah, I had to click it over again, sorry. This is how here, well, you got the point, right? Well, yeah, this is how you can decouple the data layer and the framework layer. Well, I have to be honest, I'm not doing this every time, and I'm not saying that clean architecture is one way to go and that's a silver bullet or something. It's always your judgment call. You have to like compare apples to apples and understand whether it's worth it to split the data to the data and framework or the presentation layer to keep it like separated and segregated. Well, it always depends only on the purpose, on the goals that you're trying to achieve. So in my next example, it's just one of the approaches how to implement clean architecture-ish architecture, call it Viper. In this architecture, it will be similar to MVP and MVVM as you've seen before. Instead of having view, we have view and router. View for presenting the, for rendering the data, and that's an interface. And we also have a router as a separate interface. You will see how it will work out in future, like in the next slides. And we have a presenter that has a view and router, and it can call them separately. And a bunch of interactors, which stands for I as a second letter. And the entity layer, or the data source layer, or repository, if you wish, if you'd like. The interesting part here is that view and routers can be implemented by different things. But let's make a pause here and talk a little bit. What can implement view and router? What do you think can implement view and router or view and MVP? Just, yeah, side question. I'll give you one example. It can be activity, right? It can be your activity in your app. What else? Fragment view of your group. What else? View model. Well, view model will expose an API for the view to update itself. But how about services? Have you thought about this? You still can update the view, right? You can update the remote views via widget, or you can update the notification. That is still a view. And service can implement this just as easy as any other component. So any place where you can have a control flow and access to your context, to your Android framework, where you can draw the stuff on the screen, can implement view and router most likely. Well, moving forward, yeah, Viper. Does it seem hard? View, router, presenter, interactors. I'm going to explain you this in just one slide. Sorry, it's a lot of code, maybe not as much as I have in my IDE. You see this like like 3 dots in some places. Well, Viper can be explained in 3 steps: abstraction, implementation, and client code. So for the abstraction, let's say you want to implement Viper library. You will end up having interface for view callbacks, interface for router. That's easy. Then you have an abstract class for the interactor, which has 2 generic params, request model and the response model, right? And the interactor can be created. It create observable. Yeah, for the sake of simplicity, I've just like pretended to use RxJava, but it can be any other frameworks if you'd like. So it has a protected abstract method that can be implemented by its by the classes that inherits from the interactor, that extends in interactor. Create observable, which accepts the request model, and just a simple method executes that gets a callback of consumer or subscriber. All right, the presenter here represents just a regular presenter from the MVP. That's why it has just view. So you can still use MVP if you want in some places, but then you can extend this presenter with view callbacks that can take view, as you see. You can extend it and get yourself a Viper presenter, which, as well as view callbacks, it also accepts the router or router callbacks, if you'd like. And also has the method take router. And from within take view and take router, you can unroll the stuff. You can have the callbacks like a lifecycle callbacks or something, call it like on take view, on take router, on drop view, on drop router, stuff like that, right? Then there is an implementation. Let's call I'm doing some profile screen. So my view callback interface would be my view callback, which extends view callbacks and has just one interface one method definition called show user profile. And then there's going to be like another interface, my router, which extends the router and says navigate to login. From the profile, you can log out. Let's call it this way. Let's put it this way. My interactor will extend an interactor and say that string going to be my, you remember request model, like the model that I pass to the interactor to get the data back. And the data back that I'm expecting is a byte array, the second generic param. I can also control the multithreading here. It's not essential on this slide, but create observable will just create me observable, like call the API methods from the repository or from any other data source. And then there's going to be like my presenter, which extends Viper presenter, and here you specify which view callbacks and router callbacks you expect, and then you can work from there. You can launch your interactor, and well, have to remember that interactor can have presenter can have multiple interactors, and that's totally fine to execute multiple of them, like several interactors. And the client code would be super simple. In my activity, you can implement both, or you can implement them separately in different places, in different activities, or in activity and service, as you remember. So my activity in this example implements my view callbacks in my router, and it has correspondingly show user profile and navigate to login methods. And then somewhere inside onCreate, you're probably not going to create your presenter like from code with a constructor. Instead, it's going to be injected as well by DI. So you will get your presenter, and you just call take router, take view, pass the instance of this in this case, because this activity is already implementing the interfaces. And you're done. Viper in one slide, right? Yeah, a couple of animations. OK, so which one would you use for your next $1 billion project? Let the holy war begin. No, I'm kidding. Let's vote, right? Let's vote. So who will go with model view presenter? Raise your hands. OK, you're not alone. Who will go with MVVM? Yeah, I see the Google influence, right? All right, and we're probably not going to vote about MVC, but yeah, to be honest, I was not expecting that much preference for the MVVM, because I haven't answered the question which one is better. I've just like talked through them a little bit on the high level. Well, how do you decide? How do you decide which one is better? There are several approaches that can be taken, and one of them I'm going to share with you. I would call this like a practical approach. It's just a couple of stories from my past experience when, sometimes you can assess input parameters, like input data, and take like measured decision based on this. So one of the practical approaches, one of the stories would be like real project story number 1. So before joining Atlassian, I was working in a consultancy company, in the outsourcing consultancy company. And for those of you who are aware of such business, it's a wonderful business, but you're getting a lot of projects, and the customer is not always aware about what he wants, and you're getting some sort of inputs, but sometimes they are quite limited. But you need to start to deliver from the day number 1. And after sprint number 1, you have to show something. You have to run a demo. You need to bring a value because you already own the project. So in this case, project brief was, we do have a user storyboard, like user flows, screen by screen. But we didn't have any UI, any finalized UI. We had only grayscales that were subject to be changed. And we had a part of API, for example, to log in or something. But we didn't have a bunch of other API. And we didn't know anything about the business. It was a mysterious project. So we didn't have any entities or like understanding of what's going on. So just go ahead and implement with this API and this user flows. OK, all right, we can do that. I said, and why don't we use MVP? This is so straightforward. I'm not advocating against MVP, but in this case, you remember the diagram, right? You've seen this before. In this case, yes, we can implement user stories and user flows. That's true. The green circle indicates that we're good, we're fine, we covered it with unit tests, we're good to go. But then grayscales change to the proper UI, and the classes that we're implementing these views were changed as well and has to be refactored or even like rewritten. Same stuff with API. We came up with some model layer with some repository, but then because of new business rules and because of another bunch of API, you remember, we had to like rewrite it over together with tests. So to be honest, that's not the best option in this case. But if you look into the same project brief and try to like put it on just a little bit different architectural pattern, we can see that user stories, you can recognize a Viper, right? User stories and user flows can be implemented by router and can be tested, unit tested, covered with Espresso or unit test. That's good, that's fine. Grayscale designs, when they change to the real design, we just, okay, we implement views, right? They will just stop because we didn't have to implement them in Viper. You can imagine that some of the APIs that were initially ready and initially available were implemented as a partially on the entity level because we need to provide an API, but as well we had an interactors that we also were able to cover with unit tests and everything. And yes, when new business rules and other API came out, well, okay, we wrote a couple of other interactors because those levels were like separated, and because interactors, there could be multiple interactors. That was totally fine, and the green part meant that we kept this code. So we didn't have to rewrite the interactors that we initially implemented and the router. So we at least had something like finally done, finalize it after week number 1, after sprint number 1, having no idea about what is this business about, right? Just following some architectural patterns and input parameters. Real project story number 2. In this project brief, we did have the whole UI UX available right in the very beginning. But we had private web API, and private web API is, well, it's a part of the story. It was actually a web API, and we were able to reverse engineer it with Chrome DevTools, but we had no documentation, nothing, no support, nothing. So we just had to, like try to go through the screens on the web and try to come up with understanding what this JSON means and like work from that. And again, no business rules were available. So if you go with MVP, it's going to be pretty much the same story, because even despite the fact that we had UI and UX, we didn't have, this keynote doesn't support the responsive design, so please don't be afraid of this. But basically, this 2 red circles stands for the private web API and no business rules available. And because private web API changed the model, this required the changes of presenter, and the presenter in MVP knows the interface of the view, and it has to call it like appropriately with appropriate params and things like that. So we ended up having we would have ended up changing all 3 layers. Instead, we were able to use the MVVM in this case, and it saved us a lot of time, because as soon as we've done with UI UX, we didn't need to touch it again, despite any changes of the web API or business rules available. The same stuff here. So we've changed the model, we changed the view model classes, but because view model exposes some sort of view state in this case, this view state, and it's like an observable or live data on the view state. So this view state is going to be consumed and subscribed from the side of a view, and view doesn't need to be changed. So in this way, using MVVM, we were able to come up with some finalized piece of code, part of the solution from the day number 1, just as is. And there's more to the practical approaches. Sometimes you have some weird input parameters, as I've described it right now. But sometimes you can probably end up in the situation when you don't have any limitations. API is ready, designs are ready, just go ahead, implement whatever you want, just do some architecture. Or maybe you're just curious about some architectural parts and you want to learn about them. In this case, go with scientific approach. I call it scientific, it's probably also empiric, but still, just go to the Android architecture blueprints. If you don't know what it is actually a group of Google engineers, and not only Google engineers, who create a lot of sample apps, they all implement like to-do list where you can check, uncheck, add, and remove stuff. But they implement like MVP, MVP clean, MVVM, MVVM with live data, and there is so much more to it. So for example, I just like screenshotted a part of it, but there are also Kotlin examples, and like MVP conductor, MVP Java, and loaders, data binding, all these examples. And even more, if you jump into one of them, you can see that they, like in the end of the screen, this is for MVP plus clean architecture. In the end of the page, they compare one architecture to another by number of lines or by how easy it is to test or how easy it is to understand for the new developer who joined your team and maybe we're not aware about like some reactive or observable stuff. So this is definitely a good place to learn about architecture stuff and yeah, scientific approach. Well, I would like to give you an advice from the architect. Forgive me if you didn't see this TV show, but yeah, the architect suggests use the right tool for the job. Basically, you need to use something particular just to solve your case and to achieve your goal. There is no silver bullet. Use a judgment call, measure and cut, things like that. Okay, Q&A session. Let's have a Q&A session like separately together with pizza and cola and beer probably, because we're kind of running a little bit out of time. Just one last word about useful links. There is a model app architecture talk from the Google I/O. You may be seeing this, and app architecture with Kotlin. This one is particularly good. And architecture samples. This is a URL to the repositories that I have shown you just now. And yeah, or ask me direct questions. I would love to answer. Thank you very much, guys.